In this video, we will discuss about Indian Ocean Dipole. From the name, we can easily figure it out that this phenomenon occurs in Indian Ocean and the dipole means two opposite sides. For example, a magnet. A magnet has two opposite sides, North Pole and the South Pole. So these two sides are called as dipole. When you look at the term Indian Ocean Dipole, it means there have to be two sides in the Indian Ocean with respect to sea surface temperatures. Indian Ocean lies in the tropical region. This is the western side and this is the eastern side. There is an irregular shift of sea temperature from the western side to the eastern side of the Indian Ocean and vice versa. That means if the western Indian Ocean become warmer, then the eastern part of the Indian Ocean would be cooler. Similarly, if the eastern part of the Indian Ocean warmer, then the western part would be cooler. This irregular shift of sea surface temperature of Indian Ocean is called the Indian Ocean Dipole. It is similar to the phenomenon El Nino and La Nina of the Pacific Ocean. Now the question arises, why does the Indian Ocean have a dipole? Out of the five oceans, Indian Ocean is the warmest ocean. If you look at the Indian Ocean, it is surrounded by land masses from the three sides. But on the eastern side, water from the Pacific flow between the island of Indonesia and Australia and mixes with the Indian Ocean. The tropical easterlies make that happen. Tropical easterlies are winds that blows northeast in the northern hemisphere and southeast in the southern hemisphere, and they are located between 0 and 30° north and south latitude. When the water from the Pacific Ocean enter into the Indian Ocean, it changes the surface temperature of the Indian Ocean water. Another fact is that in the northern hemisphere, the Indian Ocean is landlocked and does not come in contact with the Arctic water. That means the water of the Indian Ocean is very much warm throughout the year. These are the reasons why Indian Ocean developed a dipole. Now the next question, how does the Indian Ocean dipole work? The Indian Ocean dipole occurs in the three phases: neutral phase, negative phase, and positive phase. First, we will look at the neutral IOD phase. Neutral phase begins in the spring season. When the temperature gradually rises during the neutral phase, water from the Pacific flows between the island of Indonesia and Australia and comes in contact with the Indian Ocean. Temperatures are close to normal across the Indian Ocean. Then comes the positive IOD phase. In this phase, more and more warm water of the Pacific start flow between island of Indonesia and Australia. Remember that there are strong tropical easterlies wind that flows in this region. Now this strong tropical easterlies wind push the warm surface water towards the western side of Indian Ocean, that is near Africa. When this happens, you also need to understand about thermocline. As the surface water is warm, temperature of the water below the surface is cold. When warm surface water accumulates on the western side, the deep cold water rises in the eastern side. This process is called upwelling. Now the warm surface water on the western side will create a low pressure zone. Always remember, low pressure will develop in the region of warm temperature. Warm temperature also creates a lot of moisture. Warm air will then rise because the hot air molecules are loosely packed. Air expands when it is warmed. After reaching a certain height, some of the warm air condenses and from clouds, which resulted in rainfall. On the eastern side of Indian Ocean, you will find the ocean water to be cooler. Cold temperature is associated with high pressure. At high pressure region, air sinks because cool air is more dense and heavy. When cool air descends, it warms and it cannot hold more moisture. This warm air reduces the relative humidity of the air and the air becomes dry. This condition prevents the formation of clouds and rainfall. That's why region of high pressure will usually have dry condition. During this time, the southeastern countries and northwestern Australia faces severe drought condition. On the other side, coastline of Africa faces severe rains and floods. Air flows from high pressure to low pressure area. This is what creates the global wind belt. And the third phase is negative IOD phase. In this phase, the easterly wind become weak and westerly wind become strong. The westerly winds push the warm surface water from the western side of the Indian Ocean towards the eastern side, that is near Indonesia and Australia. When warm surface water accumulates in the eastern side, the deep cold water rises towards the surface on the western side. The warm surface water in the eastern side of Indian Ocean will create a low pressure zone. The warm air will then rise because the hot air molecules are loose. air expand when it is warm. After reaching a certain height, some of the warm air condenses and forms clouds, which then resulted in rainfall. On the western side of the Indian Ocean, you will find the ocean surface water to be cooler. Cold temperature is associated with high pressure. At high pressure region, the air sinks because cool air is more dense and heavy. During this time, southeastern countries and northwestern Australia gets rain. On the other side, the coastline of Africa faces severe dry and drought condition. Now you may have a question that why the easterly and westerly winds become strong and weak. Answer to this question can sum up from the general air circulation of the atmosphere. We know that winds moves from high pressure to low pressure region. That is what creates the global wind belt. High and low pressure system created due to uneven heating of the earth's surface because land heats faster than water. In other words, we know it is due to solar heating of the earth's surface. We also know that Earth axial tilt causes different season. When the pressure gradient changes due to rotation of Earth, easterly wind also get weakened. When pressure are lower over the poles, the strength of westerly increases. During winter, low pressure in the poles occur. The westerly can be particularly strong, especially in the southern hemisphere, because there is less land to slow down the westerly wind. That is why it is referred to as roaring 40s, furious 50s, or shrinking 60s according to the degree of latitude. Now the question is, how does the IOD affect the monsoon in India? As we have learned, during a positive IOD, eastern part of Indian Ocean becomes abnormally cool and western part remain unusually warm. The reverse occurs during a negative IOD. A positive IOD is said to be beneficial for Indian monsoon because it pushes rain towards India, and whenever there is a drought condition in India, a negative IOD occurs. I hope you found this video informative. Thank you for watching.